All right, so I always make these slides the day before. I know that the news is out that school is, at least in school, is canceled until basically the 20th. That would be that Monday when we return. So the calendar still says PSAT prep. We're not going to be doing PSAT prep. So I'm making this presentation on Thursday morning. For me, Friday morning, teachers are having a meeting at school. We're going to talk, and there'll be 10 or less of us. We're going to talk about how we're going to go forward for this. There's a lot of options we're mulling over right now. We'll have a plan. I don't know what the plan is going to be, whether it's just continuing what we're doing now or maybe a bit more interactive. There's a lot of websites out there. We have teachers, little committees formed to figure out which one we want to choose to use. So I would expect that we will make a change in how we present this. Rather than using Google Forms, I don't know, with Google Classroom, Schoology, Zoom, something like that. We're going to be using probably something different, so just be ready for it. You guys are smart enough to handle that change. But I can almost bet 99.9% sure we won't be doing PSAT prep when we come back. We'll just continue with Chapter 11. All right, here we go. All right, here's your homework tonight. Copy it down. Okay, here we go. All right, so this is area of parallelograms, triangles, and rhombi. And you're like, well, I already learned this in 7th grade. You did, and now I'm going to make it way more complicated than it needs to be. Because remember, in 7th and 8th grade, you were given these formulas, and you just assumed that the teacher wasn't lying to you. Well, they weren't lying to you, but remember, this is geometry. We got to prove everything we do. I will just say straight up, these proofs are messy, complicated, and long, but they certainly do finally prove to you why the formulas for parallelograms and triangles and rhombi are as such. The formula for you don't have a formula for a rhombi, so this will be the first one you've ever gotten for that. All right, so it's just a couple theorems, two of them, and yeah, let's just go ahead and do one. All right, here's how I would suggest. You're going to look at the proof. Obviously, we'll get started. Try not to be not an active participant, or I should say, try not to be an inactive participant. Try to be an active participant. If you want to pause and see if you can finish the proof yourself, go ahead. If you want to do a couple steps and then pause it and go ahead, but try not to just sit there and just listen to the words. Try to be active. Get your brain thinking about the logic behind why this works. Okay, so here's the first proof. We're basically going to prove why the formula for the area of a parallelogram is base times height. All right, so you're given a parallelogram, and we need to prove that the area of that parallelogram is base times height. Notice we don't have any information how long the sides are, anything like that, what the angle measurements are, and nothing like that. All we have that it's a parallelogram. So we do have all the statements about parallelograms, though. Okay, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, so forth and so on. All right, here's how we're going to do it. We're going to construct basically altitudes or heights. So we're going to go from one parallel side to the other parallel side. So we're going to construct PV, and we're making it perpendicular. And we're also going to, off to the side a little bit, we're going to make QT so it looks like that. Okay. So both PV and QT are perpendicular to side SR. Therefore, they do measure the height between the two parallel sides, the two bases. Okay, so that's just our basic instructions. Okay, now since they are perpendicular, therefore we know they're congruent. Why? Well, it's parallelogram, so therefore the distance between two parallel sides never changes. So that's just basically the definition. Parallel lines, the distance is always the same no matter where you measure it. So we got that, and obviously from the visuals right here, you can see that you have two triangles. So here's where it gets a little bit messy. Okay, so we're going to say that PS is congruent to QR. Why? Well, definition of parallelogram says that opposite sides are congruent. Okay, so we got PV, which is the I don't know, one of the legs of the right triangle, and we have PS and QR, which are the hypotenuse. Therefore, you can quickly see that those two triangles are congruent because of hypotenuse leg. All right, here's where you might want to try to pause the video and see if you can finish the proof yourself. All right, so let me give you a hint. Notice that with the red dotted lines, we have made, well, basically we made a rectangle, haven't we? And in order to finish the proof, we got to just carefully call out what we made. So PQRS is the entire parallelogram. So PQRS will be made up of, and you got to, these is going to little slightly confusion here, PQRV plus that one triangle PVS. Okay, and I can say it a different way. I could also say PQTV, right? That would be made up of PQRV plus the other triangle. Okay. All right. So what allows me to do this? Well, that's that one postulate from the other day that says that the area of a large shape is made up of the area of the subregions. Okay. That's postulate 19. Okay. Somewhere along the way, we got to literally say, though, that PQTV is a rectangle. So, well, it is a rectangle. Let's see, why is it a rectangle? Well, we can see that it has two right angles. And if it has two right angles and those are connected to parallel sides, then the opposite sides, or the opposite angles, either by saying that any two consecutive sides are supplementary, or we could say that the interior angles are supplementary. Yeah, either one of those would work fine. But the definition of a rectangle states that it's a quadrilateral with four right angles. And so I probably am skipping a step here by showing that the other two angles are right angles, but I just stated right there. We're just for the sake of simplicity, we'll leave that part out. Okay, so we got PQTV as a rectangle. How does that help us out? Well, what's the formula for area of a rectangle? From last class, we know that a rectangle's area is base times height, right? That's just the definition or the formula for area of a rectangle. So let's see. If PQTV is a rectangle, three statements up here, I say that PQRS is made up of those particular pieces, and PQTV is made up of those particular pieces. And since PVS and QTR are congruent, I could do a quick substitution, and therefore you could say that those two are congruent as well too. So therefore PQTV is also the same as PQRS, therefore it must have the same formula. So just using a little bit of substitution. Okay, so what do we just prove? We prove that the area of a parallelogram is base times height, and that's 11.2. 11.1 was area of a rectangle, which was also base times height. And now we have area of a parallelogram is base times height. Our most favorite formula, base times height. Okay. All right, sounds easy. You know, if you were in 7th or 8th grade, you get a problem like this, and you'd simply measure multiply base times height, and you get 10 square feet, and you'd be, yes, great student, but you're in high school in geometry, so they're going to make your life miserable, and instead of giving you nice, friendly numbers, no, they won't be decimals, they're going to give you ugly things that will require you to use special right triangles. So just recall, for 45, 45, 90, the two legs are x, and the hypotenuse is x root 2. And for a 30, 60, 90, the short side is x, the hypotenuse is double x, and the long leg is x root 3. Okay, remember that. You're going to need that, right? For special right triangles, you're going to need that to complete your homework and as well as do some classwork today. Okay, so you might want to write that down or rewind, go back and forth to it. All right, so this will be an example of what homework will look like. It'll say calculate the area of this parallelogram, all right? And notice they don't give you the height, but they do give you that the base is 10, and they give you one of the angles is 45, and they give you one of the sides is 8, okay? So how could we do this? Well, we know it's a parallelogram, right? So we know the area of parallelogram, base times height, and we know the base is 10. So all we have to do now is figure out the height. Well, just look at the one triangle that has H as one of its legs. Okay? So we know it's a 45, 45, 90 triangle. And so we know that's the general idea for 45, 45, 90. If the leg is X, then the hypotenuse is X root 2, or root 2 times X. Either one's fine. So a little bit of scratch work off to the side, since we know that on our parallelogram, and which forms that right triangle, that the hypotenuse is 8. So that means that 8 is equal to root 2, not x, I'll just use h, right? Okay, So just solve for h. So that means divide both sides by root 2. We can't have a square root in the denominator, so we rationalize the denominator. Remember that. Multiply both sides, or the numerator and denominator, by root 2 over root 2, which is basically 1. So we get 8 root 2 over 2, which reduces to 4 root 2. So that's my height. So my height is 4 root 2. Multiply those two together, and you get 40 root 2. Remember in 7th grade when they gave you a nice parallelogram where the base was 2 and the height was 1, and you did 2 times 1 and you were done? Well, no more. Okay, so be ready for some ugly ones like this. I guess, I'll justify it as a teacher. At least it gives you practice with special right triangles. I'm currently going through the Algebra 2 book for next year, and absolutely positively, special right triangles, I'm not saying every single lesson, but you will see it frequently enough. So the more you mess with special right triangles, the more you commit it to memory. Okay, one more proof. Well, let's see. Yeah, we are literally going to figure out why the area of a triangle is 1/2 base times height. Now, when you were probably taught this in, I don't know, 6th, 5th grade, somewhere around there, they took a parallelogram or a rectangle, cut it in half, and just said, hey, check it out. It must be 1/2 of the parallelogram, so 1/2 base times height. But they never proved to you that cutting it diagonally, a parallelogram, literally makes half of or cuts it into 2 equal parts. Well, it's geometry, so that's what we got to prove. All right, here we go. So that's the given, and that's where we're going. Oh, that's a lot of space there. Yeah, ends up being complicated. And this is also why they don't teach it to you in 5th grade. Okay, so here's how it's done. Once again, if you can run forward and finish the proof, do it. If not, catch a couple hints, but just be active in your participation here. All right, so here's what I want us to do. We're going to construct 2 parallel lines. The first parallel line is going to go through X, and it's going to be parallel to YZ. So that, and it's going to end at point W, somewhere along that line. The second one is going to go through Z. It's going to be parallel to YX, and it's going to end at point W. Now, I didn't establish point W until I found out where the 2 parallel lines intersected, and I made that W. So don't assume that I already knew where W was. I didn't until where I saw where the 2 lines intersected. Okay, so we can't assume right now that it's a parallelogram, even though it is. We can't assume that. Why? Because I don't know how long ZW is, and I don't know how long XW is. All I know is I made lines parallel. Now, if I were to really do this proof in detail, I would need a bunch of lines. Because what I'm going to do, I can do that by construction. So what I'm going to do now is I'm going to show you that why these 2 triangles that we just made are congruent. I mean, there's lots of ways to do this, and I'm skipping the steps. I'm just going to say that they're congruent. Well, clearly they have a reflexive property for XZ. I think you can see that one. But what I want you to think about is XZ as a diagonal between XW and YZ. It's a diagonal between XW and YZ. Therefore, you'd have alternate interior angles, right? And then what I want you to do is that same diagonal is also a diagonal for YX and ZW. So therefore, you'd get another set of alternate interior, a different set. Therefore, you have 2 sets of angles, and you have that one reflexive property. So those 2 triangles are congruent by ASA. Now, I realize if we were in class, I could probably do this a little bit better to help you understand it. But I think you can probably guess, or you can understand the logic of those 2 triangles are congruent. Okay, so now I've got that those 2 triangles are congruent. Where am I going with this? Well, as always, it's geometry. So you show that 2 triangles are congruent. Then you show some pieces parts are congruent by CP/CTC. So the 2 pieces parts that I needed to show this was a parallelogram were the opposite sides. So XW and YZ and XY and WZ. Now I have shown that they are congruent. Therefore, it is a parallelogram. Why? Well, the definition of parallelogram says that opposite sides are congruent. That was one of those converses that we had. Okay? If you can show that the opposite sides are congruent, then it's a parallelogram. Okay? So we did all that work to show it's a parallelogram. Why? Well, we know that by postulate 19 that the area of the parallelogram is made up of those 2 triangles added together. Makes sense? Right? So the whole parallelogram there would be the 2 triangles added together. Okay? And well, let's see. We already showed that the two triangles are congruent, and postulate 18 says that if two things are congruent, then their areas are congruent. So therefore, I can say that xzy and zxw are two. Right? If you add those two together, you get two of them. I just picked xzy because that's the black one, and that's the one that we eventually want to get to. Make sense? Okay. Hopefully you can see how this ends. All right. So let's see. We got the area of a parallelogram is equal to 2 times the area of one of those triangles right there. Well, I know what the formula for area of a parallelogram is. Area of a parallelogram is base times height. Therefore, all I got to do now is simply divide both sides by 2, and I get that the area of a triangle is base times height. That seemed like an awful lot of work, and it was. But we did prove it to ourselves, so now we can use that. And this is also why it's not done in 5th grade. You may have learned it even in 4th grade, 1/2 base times height. Okay, but now we can use it. This is theorem. This is the last theorem of the day. This is what's always written in every single math book, 1/2 base times height. I don't know of any student that actually uses that formula. Everybody uses this second one. And it's not in any book either. Like base times height divided by 2, yet everyone uses it like that. Okay, you can use either one, I don't care. Okay, a couple quick examples and we're done for today. All right, here's the first one. So it says calculate the area. Clearly it's a triangle. All right. Can anyone see what kind of triangle it is? Yep, it's isosceles. So let's see. We draw a diagonal straight down the middle. That would be our height. And we know, since it's an isosceles, that the altitude breaks the base into 2 equal parts. We've done that many times before, so that if the whole base is 6, then one side is 3, and the other side's it's a perpendicular bisector. Okay. So let's see. The formula says base times height. Notice I'm using the formula that we all use, not the one that's in the book. Base times height divided by 2. Well, I know the base is 6. All I got to do is figure out the height. So let's see. The height. How are we going to get the height? Well, it is a right triangle. Therefore, I have 2 sides. Therefore, the height is the third side. I could use the Pythagorean theorem. Just make sure you plug the numbers in the right spots. So 8 is the hypotenuse. 3 is one of the legs, and h would be the final leg. Let's see, that'd be 64 and 9. 9 minus 64 is 50. Ugly number, really ugly number, yeah? It's high school geometry. Or, the days of easy numbers are over with. So just get over it and just deal with the ugly numbers. So that's our height. We plug it into the formula. Looks like we can divide by 2, so the final answer is 3 root 55. We are also really lazy in high school algebra. I know in pre-algebra and even before that, they make a really big deal about, hey, it's got to be in square units, and now we're just saying 3 root 55. So it's kind of, poor math techniques to never put the units, but it is done, and we just assume that it's one of those assumptions that we make that we say, well, of course, everyone knows it's in square units. Okay? All right. If you need to rewind that and watch that one, please do. I think we're going to do one more example and call it a day. No, 2 more examples. No, maybe one. We'll call it a day. All right, let's do one more. It says calculate the area. Calculate the area. What kind of triangle? Yeah, this one's an equilateral. So we got an equilateral. Well, if it's an equilateral triangle, what do we know about equilateral triangles? Yeah, we know that all the angles are 60 degrees. Therefore, this is a 30, 60, 90 triangle when you include the height. Does that make sense? Equilateral, it means all the angles are 60. I just bisected one, so the top is 30, the lower right is 60, and obviously the other one is 90 degrees. Okay, so it's a 30, 60, 90. Remember, the short leg is always x. The hypotenuse is double x, and the long leg is x root 3 or root 3 times. I'm not sure. I went on a website and just copied. I didn't want to make one myself, and this is how they wrote the formula, and that's fine. Okay. We good? All right. So all we got to do is plug and chug through this calculation. Let's plug in the numbers. The base of the big triangle, obviously, is 6. Well, let's see. The height is on the 30, 60, 90 triangle. Let's see, x is equal to 3. That's the short side. and the height is root 3 times x, or in other words, 3 root 3. You get that? Because, x was 3. Okay, so we're going to substitute that in for h. Let's see, 6 times 3 is 18, divided by 2 is 9, so we get 9 root 3. Okay, enough of that. All right, let's get on to the real thing, the brand new thing of the day. So we haven't done anything with rhombi. This is a formula that kind of comes out of the blue. Now a rhombus also is a parallelogram, right? And remember, parallelogram is base times height. But this is going to be an additional formula. So we can always use base times height in a rhombus, but here's an additional formula. Back in the last the chapter that we had rhombi in, we found out that their diagonals are both perpendicular and they bisect each other. That was one of the things from way back when. We're going to use that one in this one proof as well too. But it turns out that if you have a rhombus, that the area can also be calculated with its diagonals. And if you take the two diagonals and you multiply them together and divide by 2, it turns out that's the area. And that's what we're about to prove. Okay, so that's what we're going to prove, is that you take the two diagonals, multiply them together, and divide by 2, and you get to the area. Let's see how we can prove this one. This one's a little bit easier. I bet you all could probably do this one without. There's no extra constructions or weird things. You can kind of see you got a whole bunch of triangles. Mess around with the triangles. I bet you can prove this. Okay, just one note on the diagram there. The D1 means all the way across. D1 is the distance of AC, and D2 is the distance of DB. Make sense? Okay, so here's how we're going to start off. I'm just gonna say, and I could have picked any two sides. There's 4 triangles there. I'm gonna take 2 of those triangles, join them together, and make one big one. So that means out of the entire rhombus, I'm gonna get 2 triangles, ADC and ABC. Now I easily could have chose any other 2 as well too. I just chose those 2. Okay, nothing special about those particular 2. Can you see which ones I chose? ADC and ABC. Okay. Why are they congruent? Well, let's see. Well, clearly they share AC, so that's reflective. It is a rhombus. The definition of rhombus is it's a parallelogram, so opposite sides are congruent. Well, there you go. You got an SSS right there. Okay, I left off the stating that AD is congruent to BC and DC is congruent to AB by definition of parallelogram. I just went ahead and just said the 2 triangles are congruent by SSS. You with me? Okay, so here's gets a little bit, be careful what I'm saying and make sure you understand what I'm gonna do here. So the area of one of those triangle, ADC, just one of those, ADC, that would equal be 1/2 base times height. So what's the base of ADC? Well, the base of ADC would be D1, right? So you can see the 1/2 base times height. So I got 1/2 base. The base would be D1. Why am I saying half of D2? Well, D2 goes all the way from D to B, and I only need from the intersection of the 2 diagonals to D. That would be the height of triangle ADC. Okay, we know from that one theorem a long time ago that the diagonals of any rhombi intersect each other, they bisect each other, and they're perpendicular bisectors. Okay, so I do know that if I took half of D2, that would be the height of triangle ADC with base AC. That's a whole lot of words. You may want to rewind that and listen to that one again. Okay, so there's my formula just for ADC. Okay, I also could have done this for ABC as well too. I chose not to. Well, let's see. 1/2 times 1/2 is 1/4, right? That's just multiplication. And we know that for the whole rhombi, it will be those 2 triangles added together. Now, once again, that's the old postulate 19. Okay. Well, in the second step right there, I said that ADC is congruent to ABC, right? So therefore, I can combine those 2, ADC and ABC, into one. I chose ADC. And that's postulate 18. It says that any 2 congruent figures have congruent areas. Well, am I at the end? Well, let's see. What did I just do? Well, let's see. I could do a quick little substitution, right? So what I could substitute is is look at the, let's see, 1, 2, the third line down. I'm sorry, the fourth line down. I said the area of ADC is equal to 1/4 D1 times D2. But I need two ADCs. You see that? See that? Fourth line down, 1/4 D1 times D2. That's the area of ADC. And the second to last line says 2 times ADC. So if I do 2 times 1/4 D1, D2, I would get a half. And that's what I was trying to get to. So it turns out, for any rhombi, take the two diagonals, multiply them together, divide by 2, and you get its area. That's our last theorem of the day. Okay. Also, most people would say D1 times D2 over 2. Okay, that one right there. More useful one. All right, so what do we have? A total of 3 theorems today. For homework tonight, obviously, like I said, you're in high school geometry. They're not going to give you friendly numbers. It's going to require a little bit of thinking. So it's not like it's you're back in 7th grade just doing base times height dividing by 2. It will require a little bit of work. Okay. If there's any questions, make sure that you send me an email. You guys have a wonderful spring break. Hopefully the chaos going around us calms down, and we'll let you know as soon as we know what the system we will have when we come back after spring break for class. I anticipate it's going to be probably Schoology, Zoom, or something like that, or Google Classroom. And we'll let you know via email as soon as we know. So have a wonderful spring break, and I will see you, Monday after next.